Good morning everyone. Today we will discuss about Unit 5, which is known as correlation and regression. So first we have to know that what is a correlation. Correlation is the combination of two words that is known as co and relation. Co means together, relation means connection. Co means together, relation means connection. Here we are telling about two variables, how they are related. One variable, how it is related, another variable we are telling, that is known as a correlation. See this picture here. In a summer season, the ice cream sale is increases. So depending upon a weather, ice cream sale is increases. If ice cream sale is increases, that means we can earn a money. So that means depending upon a season. So depending upon one variable, it will be related to remaining variable. So which is known as correlation. Correlation means one variable, how it will be depending upon another variable we are telling, that is known as a correlation. Topics to be covered in this unit: applications, scatter diagram, Karl Pearson's correlation, and Spearman's rank correlation coefficient. So first we are discussing about applications. So here, see this picture, we are seeing two applications. So one is treadmill, another one is some solar system. See the treadmill, if you run more on a treadmill, you burn more calories. That means depending upon our fastness of a run, so the calories will burn. See the second example. So weather, depending upon a weather, if sun shines grows, that means the temperature is very high. In that case, the solar system will generate more power. Okay, so one is depending upon another one. So not only this one, so in some cases demand and supply will depending upon one and another. So in all the cases, using the correlation we are doing. In some situations, in mathematically we cannot calculate directly the correlation value, how one variable depending upon another variable, the exact correlation value we cannot find out directly in a mathematical sometimes. So in that case, using this statistical method, we are finding that correlated value. Methods of studying correlation. Here we are having three methods. The first method is scatter diagram. Second one is Karl Pearson's correlation coefficient. Third one is known as the rank correlation coefficient. Right? Types of correlation. Next we are having, here we are having three types of correlation. One is positive correlation. Positive correlation means in a graphical representation, if x values are increases, so depending upon x values, y is also increases. So here we are having graph in a increasing mode. So that is known as a positive correlation. So this is the scatter diagram, that is known as a graphical representation. So next one is negative correlation. So negative correlation means if you increase the x values, y will be decreases. Sometimes y will be decreases. So y will be decreases means that can be taken as a negative correlation. And the another one is no correlation. That means, so here x values and y values they are given. So here the points are, we are plotting like this. Here we are not having an increasing or decreasing order. So that means here one variable does not depending upon another variable, the values will come. So here there is no correlation. There is no correlation between x and y variable. So these three are known as a scatter diagram representation of a correlation. Scatter diagram is graphical representation of a correlation. Examples of types of correlation. See this example, demand and supply of a product. If you take the demand and supply, if demand is increases, supply will also increase. Suppose if you are taking online sale. So in online sale means they are giving the percentage, 50% discount, 70% discount. So discount is increases, your sale is increases. Automatically sale is increases. So sale is increases means supply is also increased. So that is where we are taking the the example for positive correlation. For the negative correlation, I am taking the example is age and reliability of a car. So depending upon the age, so first year the reliability of the car is 100%. So moving to years, so if you are taking the 5th year, if you check the reliability of the car, it will decreases to 50%. So if age increases, the reliability is decreasing. So we are getting graph in a negative correlation. Here representing same thing only. So for of R, here R is the representation for a correlation value. So exact R value we are finding. That means how much percentage it will be correlated, how much value it is correlated we are finding. So the interaction of R can be defined as, see this graphical representation, the R value is always lies between minus and plus 1 only. If you are having 0, that is known as a no correlation. If you are having the value R lies between 0 to plus 0.5, we are having medium positive correlation. So if R is equal to 0.5 to plus 1, so we are having that R is the perfect positive correlation. Suppose if you are having 0 to minus 0.5, so which is known as the medium negative correlation. R equal to minus 0.5 to minus 1, which is known as a perfect negative correlation. See the example. So in this example here, so they are given R equal to plus 0.08. Plus 0.08 means that is known as a medium positive. And sometimes they are giving R equal to minus 0.72. Minus 0.72 means which is known as a perfect negative correlation. Sometimes they are giving R is equal to 0.98. 0.98 means it is lies between 0.5 and 1.0. That is known as a perfect positive. Suppose you are getting R equal to 0. So that is known as a no correlation between X and Y, two variables. Right? For finding the exact correlation value, this one is introduced by Carl Pearson in the year 1867 and 1936. Okay, the Carl Pearson correlation quotient is we are denoted by R. It measures the degree of relationship between two variables X and Y. So now the R can be written as, the correlation coefficient R can be written as covariance of XY by sigma X into sigma Y. Again, covariance of XY can be written as 1 by n into summation Xi Yi minus X bar Y bar, or this is also can be written as 1 by n into summation Xi minus X bar into Yi minus Y bar. So you can use any one of the formula for covariance of XY. Next, sigma X. Sigma X is, this can be written as, this is the standard deviation of X. So this can be written as root over 1 by n into summation Xi square minus X bar square, or this is also can be written as root over 1 by n into summation Xi minus X bar whole square. So you can use any one of the formula. Same as it is, we are writing sigma Y root over 1 by n into summation Yi square minus Y bar square, or this is also can be written as root over 1 by n into summation Yi minus Y bar whole square. So using these values we are finding R. So depending upon the R value, we are telling that is a perfect positive or medium positive or a negative correlation or no correlation, medium negative correlation we are telling. But that R value is always lies between minus 1 and plus 1 only. Right? Next, Spearman's rank correlation quotient. So sometimes depending upon the rank, we are finding the correlation. So that means, see this example here. See this example here. Here we are having 4 types of chocolate. So depending upon the taste and quality of the chocolate, we are giving the rank. So in our problem, depending upon the X and Y values, we are giving the ranks. So using that ranks, we are finding the correlation value. Okay. So the rank correlation quotient can be defined as the Spearman's rank correlation quotient is calculated when actual ranks are given. Sometimes they are giving if they are giving directly ranks, we are using Spearman's rank correlation quotient. Sometimes they are given ranks are not given and non-repeated grades are given. Sometimes they are not given ranks and they are giving the non-repeated grades. In that case also we are using the Spearman's rank correlation quotient. And in sometimes ranks are not given, repeated grades are given. In that case also using this Spearman's rank correlation quotient we are finding the correlation value. Here Spearman's rank correlation quotient is we are represented by rho and is non-parametric measurement of strength and direction of the association that exists to ranked variables. So the Spearman's rank correlation quotient can be defined as rho is equal to 1 minus summation di square by n into n square minus 1. Here n is known as the number of observation and di is known as the deviation of ranks of x values and ranks of y values. Here we have to know that no rank is repeated. So for the given x and y values, we are giving the ranks, we are denoted by Rx and Ry. We are taking the deviation, that means difference of Rx and Ry. So that is we are denoted by Di. Taking the summation of all the deviations, we get summation Di square, right? So we are substituting here, we get rho value. We are substituting here, we get rho value. So this formula for if no one rank is repeated. The properties of a correlation quotient. The Spearman's correlation quotient values are like this. If rho is equal to +1, that is known as a perfect association of ranks we are having. If rho is equal to 0, it indicates no association with the rank. If rho is equal to -1, there is negative association with the ranks we are having. Right? Suppose if any rank is repeated, in that case, so depending upon a x values, if any value is repeated, in that case we are taking the average and we have to write down the ranks of that one. If any rank is repeated, in that case we are using Spearman's rank correlation quotient formula is rho is equal to 1 minus 6 into summation di square plus m1 into m1 square minus 1 by 12 plus m2 into m2 square 1 by 12 plus up to so on by n into n square minus 1. Already we know that di means the deviation of two ranks Rx and Ry, and here m is representation for so which rank is repeated, how many times it is repeated, we are taking that one. Suppose 2 is repeated 4 times, that can be written as m1. In the place of n1 we are taking 4 into 4 square minus 1 by 12. Same as it is, we are considering y ranks also. In y ranks 2.5 is repeated 2 times, so that can be written as 2 into 2 square minus 1 by 12, and 4.5 is repeated 3 times, plus we are taking 3 into 3 square minus 1 by 12, like that we are taking. So this is for repeated ranks and the previous one for not repeated ranks. Spearman's rank correlation quotient. So this Spearman's rank correlation quotient is also always lies between -1 and +1 only. So this is about correlation. Thank you.